So let us start with the adopter design pattern. So what is an adopter design pattern? It is a structural design pattern which allows the incompatible interfaces to work together. That is the main point behind the adopter design pattern. And the name also suggests the same. So you must be having some legacy code and your client must be expecting something different. At that point of time, you can introduce an adopter layer which allows them to communicate with each other. So let us try to have an example and we'll understand what does it actually mean. So I'll just create a new class. Let us say adopter.cpp and let us start IOStream, using namespace std. Now, the easiest example that I would give you is, let us say you have a payment system. Now, for now, let us assume that you have a PayPal payment system. Now, there are some certain APIs that are exposed by the PayPal. Let us say it is an API called Pay, which takes an amount and it pays. It does the process afterwards, right? Now, at some point of time, the API changes. Let us say they make it send payment instead of just pay, right? So now what are you going to do in your code? Are you going to change, are you just going to change the pay method to make payment at all the places, or you are going to do something else? So that is the point where adopter layer comes. So let us say we have a class called PayPal API, right? And inside this, let us say we have some public method, which is void send payment, right? Double amount. And we are just going to see out that paid amount using PayPal, right? So with this, you have just created an PayPal API. And let us say this is the new API. Earlier, what used to happen is, I'll just comment it out. Let us say earlier we were having a method called pay, double amount. This was the method earlier being used, but now they changed the name to send payment, right? So in your code, are you just going to change the name of pay method to send pay everywhere? So to resolve this issue, what you can do is you can just create an interface. Let us say you create a class payment processor, right? Inside payment processor, let us make some virtual method, which is virtual void pay, and it takes a double amount, right? Along with this virtual destructor payment processor, and we can just leave it blank. Let us say you can make it default or leave it blank. Anything is fine. Now you have created an interface. Now you can see that it matches the previous version, right? Earlier we used to have pay. So we have created an interface which still has the pay method, right? So what I'm going to do is I'll create a class PayPal adopter and I'll just implement payment processor, right? Inside this, I need a PayPal API instance. So I'll just say, let us say it will be passed to us. So PayPal API pointer we will be having PayPal. It will be private, and rest everything I'll just keep it public. PayPal adapter, PayPal API pointer with API, and we can use initializer list. So I'll just say, okay, PayPal API, right? And we can leave it empty. Okay, here the name is incorrect. Now, once we have this constructor done, I'll just have to override the pay method, pay double amount, and we can just say that PayPal is used to pay send payment of an amount value. Correct. Now, if you want to use it in main PayPal API, let us say, and we can just have PayPal processor, which is a pointer, PayPal equals to new PayPal adapter. We'll create an adapter and we will just pass the reference of PayPal API, right? Like address of PayPal API. And it will be taken as the pointer inside, and then we can use it to send the payment. Now, let us say I have PayPal paying 50 rupees, let us say. And at the end, we can just delete the PayPal object and we can just return 0. Right. So if I try to compile it in G++ adapter dash O adopt, it compiled successfully. And if we try to print it, it prints the log correctly. Now you must be thinking that why did I use an interface like payment processor? Why not just directly having a pay method inside my adapter? Why do I need uh, like an interface for it? For now, you are having a PayPal payment method. Let us say in future you must be having something different. Let us say UPI through Google Pay or through Phone Pay. Now, all of those classes, their APIs will be very different. So in that case, what you can do is the same interface will be implemented by all the adopters, and you can use the same method for the payment. Like you don't have to worry about, say, PayPal is using send payment and might be possible the phone pay is using make payment. So in that case, the developer might get confused. So that is the point why we use the adapter design pattern, because the same interface is going to be used by different APIs. And since they are incompatible, so now you are making it compatible to the client. That is the main objective of using this interface and making the API exposed to the client, which is the main right now. So I hope you understand the adapter design pattern.